quietly. I think I have to start having you come in and put your heads down again. I think that's what we're going to start doing, because for some reason, we're not coming in the room quietly anymore. So next week when we come in the room, we're going to have to start putting our heads down again. When we come back from lunch, when we come back from recess, when we come back from specialty, we come in and put our heads down. And then when I say, okay, let's get ready to learn, then you can put them up. All right.
All right, boys and girls. Today, you have a worksheet on your desk, and it's okay to put your name on it, but please don't do anything else to it. So if you want to put your name on it, that's fine, but then hands off, and just put them on top of your desk, and if you need to scoot it to the side, that's fine. Today, we're going to be talking more about weathering and erosion. Can you say that?
Weathering and erosion.
And we kind of talked about it a little bit when we started our soil unit, but today we're going to go into it in more detail and learn about what are the differences between weathering and erosion, okay? So, this is an example of either weathering or erosion. So we're going to watch a video, and you guys are going to kind of think about which one it is, and then we'll talk about it more, and hopefully by the end of the lesson you'll be able to tell me which weathering or erosion created this beautiful arch that's on the Utah license plate.
Let's try some word association. I'll say a word. You just say the first word that pops into your head. Ready? Day.
Day. After day, the earth is worn down by water, ice, wind, and chemicals.
Night.
Night after night, the process continues, relentlessly, unabated, pounding on the earth.
Interesting. Dog.
Doggone it! That mountain used to be higher and more jagged.
Aha! I think I see a problem. It goes back to your childhood. You are obsessed with erosion.
Bill Nye the Science Guy.
Erosion Demolition, Inc. Give us the time and we'll whirl away anything you got.
Rocks are solid. They're rocks. But every rock on the Earth's surface will be different tomorrow from the way it is today. They're eroding. Water, ice, wind, sand, and chemicals are constantly crumbling mountains, flattening hills, widening valleys, and deepening canyons. Erosion never stops. Never! Take a look at this. It's our water flow erosion model of science. It's a piece of mineral salt and a hose. Now watch what happens when a stream of water slowly flows over. It's changing. The water is carrying some of the solid away. We say it's eroding. Now this takes time. This is our expanding ice bottle of science. When we freeze the water inside with this ordinary household liquid nitrogen, the liquid water turns to solid ice, and it expands. It can split the bottle right open. See? Now, when liquid water gets in cracks and rocks and freezes, the rocks split open. This is another cause of erosion. Well, it's coming along. See, the rock is changing. Very, very slowly. Changing. See, every particle of sand carries away a little bit of mountain. So that after a while, the mountains change. They're eroded. Okay. How do I fix that? Hello? Hello? Anybody?
Got it.
Look, the water has worn a little canyon. See how deep it is? Landscapes all over the world are always changing. It's erosion.
Okie dokie. Alright, so we're going to do a little experiment, so if you guys can make sure that you're on the side of your worksheet that has the M&Ms on it. That's the front of the worksheet, so make sure you're on that side. We're going to do a little experiment together. Alright, I brought my favorite treat today, peanut butter M&Ms for this experiment. And maybe if you help me, maybe I'll let you have some. Okay, I have right here a jar. Okay, I'm gonna make sure it's nice and clean so you guys can see inside of it. And I'm gonna fill it with water. Put more in there. I'm gonna stick 2 of these red M&Ms into the water. Okay, is everybody watching? I'll stick these into the water. Put the cap on. I'm going to go row by row. Did anything happen to the water when I did that? Did the water look different? Or does it still just clear water? Still just clear water? The first part of your worksheet says, what do you think will happen when I shake the jar? Go ahead and write a prediction on your sheet. What do you think will happen when I shake the jar? Will the water stay the same? Will the M&Ms disappear? Will they suddenly be in my stomach? The water's clear right now. What's going to happen when I shake the jar? Put your hypothesis on that first line. So on the first line. So where it says, making a hypothesis, those 2 lines right there on the top of the page. I'll put the document camera on so you guys can see what I'm talking about. Right here, this is where you're going to make a hypothesis. What will happen when I shake the jar? Jojo, what do you think will happen? You think the water will turn red? Thumbs up if you agree with Jojo. Thumbs or hand, raise your hand if you have a different hypothesis. Christian, what do you think?
The M&Ms are going to disappear.
You think they'll disappear? Andrew, what do you think?
It'll turn red or brown because the M&M will split.
Trey, what's happening to the M&Ms?
The M&M's color is
It's going away a little bit. Should I shake it?
yeah.
Okay. All right, here we go. Sorry, Trey. All right, shaking it. Kind of messy. What happened to the water, Kimmy?
And the water turned into a different color.
It turned a different color. Did it turn green? Where do you think the red came from, Ryan?
We don't have enough M&Ms, so it's not that red.
Yeah, maybe if we had put more M&Ms, it would have been a darker red. But she's right. The coloring came off the M&Ms on the outside. Yeah, TJ?
What I said for my prediction is the water will turn red and the M&Ms will lose color.
Oh, that's exactly what happened. You guys can't really see. I'll walk around so you can look. But the M&Ms are now white, which is what would happen if you sucked on them in your mouth. They would turn white. Yeah, Michaela?
I said the water will turn pinkish reddish and the color will
Yep, that's exactly right. You had the same one as TJ. Go ahead and write on the next line where it says what actually happened. Write what actually happened. The water turned red, the M&Ms lost their color. Yeah, Laurel. Yeah, of course I can. Do you see how the M&Ms are? They are because they're the peanut butter ones. Does anybody else want to see the jar while they're writing it? Okay. You see the M&Ms?
Wait, where?
They're right there. They don't even look like M&Ms anymore.
I want to see.
They look like Whoppers now. Sorry, Riley. Yeah, of course you can see.
They look like, the things that,
They look like Hershey's cookies and cream bites now.
they look like the things that,
Make sure you put something down under what actually happened. And then underneath that it says, was my hypothesis correct? Circle one, yes or no. It is 100% okay if your hypothesis wasn't right. It's not about being right, it's just about making a guess and then seeing what happened. Yeah, Maddie?
or you had again. I said the water will be red and the water will be white. Because I put that all the stuff on it and that's okay.
Maybe you've seen that before. Yeah, that's awesome. Okay, Chelsea.
If you only guessed one of the things that happened, you still put yes?
Sure, yeah. If you guess one thing, that's fine. Yeah, Laurel. No, we don't have time for that, but maybe you can try it at home. But when we put the M&Ms in here and we just let them sit there, nothing happened. There's some color that was coming off, but the big difference was when I shook it. And that is called weathering. Can you say that? Weathering. So we weathered down the M&Ms. When I shook the water, that motion, the M&Ms were bouncing against the sides of the jar, and the water particles, can you say that? Particles, water particles, they were rubbing on the M&M and taking off the color, and then now it's in the water. So that is weathering. All right? Everyone understand that? Now I'm going to show you erosion, okay? That was weathering, taking the color off the M&M. Now watch, I'll show you erosion. Make sure your eyes are over here. This is erosion. What did I just do? TJ.
Dump the water.
I dumped it out. And now where is it going? Where's it going, Ostani?
In the sink?
It's going in the sink, down the sewer system. And it's currently eroding. All those materials that came off the M&M, all the color particles, all of the artificial coloring that they put on there in the M&M factory, we weathered all those off, and then it was in the water, floating around. And then when I poured it, it eroded. That means it was transporting from one place to another. Erosion is transporting from one place to another. Let's say that all together. Erosion is transporting from one place to another. That water is probably still moving somewhere. It's probably still eroding. And it probably won't be done until it gets to the sewer system, right? Okay.
Teachers, please excuse Backpack Club members to come to the office. Thank you.
All right. Now go ahead and flip to the back of your worksheet. And we're going to make a little chart together of weathering and erosion. Because guess what? They are two different things. Can you say that? Two different things. They are two different things, weathering and erosion. Who thinks they have a good definition for what weathering is? TJ. What did I do to the M&M?
The M&M in water and the M&M lost the color.
Exactly. What's another way you could say that could apply to everything? Aralia?
And they changed, the M&M changed it into a different color in the water too.
So what we did was we broke up the elements. We broke them apart. When I shook the jar and it clanged against the sides and the water was moving all over the place, we broke up the materials. So right here on your weathering side of your chart, you can write down breaking down. Breaking down means to take apart, put it into pieces. They were all in one piece on the M&M, and then we broke it up to a bunch of smaller pieces that were floating in the water. Breaking down Earth's, the planet Earth's materials. And that can apply to anything. A rock is a material of the earth, an M&M is a material of the earth, leaves, mountains, rivers. If you're weathering something, you're breaking it up and making it into smaller pieces. Okay, so what are some examples you guys think of weathering in real life? What are some things in nature that break up Earth's elements? Ruben? What was that?
Rocks.
Rocks? Well, that's an Earth's element, so what would break up a rock? So it would have to happen naturally, like water. So right here you can write examples. And one example that Ruben just gave us was water. Water is a great thing to weather an object with. Just like we saw in the Bill Nye, where he had the water on the rock and he let it sit there and it takes a long, long, long time. But eventually little tracks in the rock were cut by the water. And do you know what? That is how, give it a second, that is how this was made. For millions and millions of years, water hit this rock. It used to be just one rock. And for millions of years, water hit it right here. And eventually, it was flat, and eventually it went a little bit inside, a little bit inside, a little bit inside, over hundreds and hundreds of millions of years. And eventually there was a hole. And as the water kept going through the hole, it broke up more of the rock and made the hole bigger. And now there's not water that goes through there anymore, but that's how arches are created. Arches are created through weathering. Can you say that? Arches are created through weathering. Wait, are they created through erosion? No. What's erosion, TJ?
Where you transport one place to another.
Exactly. That's exactly right. Who can tell me another example of something that would weather an object down? Jasmine? Wind. That's a great one. Wind. Just like how on Bill Nye, do you remember when he had that air blasting gun and he was blowing on the top of the mountains? And did you guys see how they were changing shape? They were changing shape because he was weathering them down with the high pressured wind. Yeah, Michaela?
They were going like flat on the mountain.
Uh-huh, exactly.
Flattened.
Yep, and they were weathering down. Taylor?
Once I went to a canyon and the person that showed us, he showed us that water, like there used to be tons of floods, and they would go through that exact same place and make it deeper and deeper.
Uh-huh.
And he did a little experiment where he poured water to show the weathering, and then the sun baked it so it hardened.
So there's another example of weathering. What did you just say at the very end?
That he...
What baked it?
The sun.
The sun. Heat is another example of weathering. Heat. If something is super, super hot, sometimes little parts of it can fall off, or if it's hot, it can break apart. And when things are hot, they're not always as stable as they once were when they're at room temperature. So that's another example of weathering. And then, can anyone think of another one, Andrew?
Pressure.
Pressure, that's a great one. Pressure, and that is kind of what Ruben was talking about when he said the hammer. Because if you slam a hammer down on a rock, that's a lot of pressure all at once. And then it would break up. Michaela?
I was going to say something. If you leave like a glass too long in a freezer, it'll like break.
So there's another one. What's another word for that? What do you put in your drink if you want it to be cold?
Water.
Ice. Ice. There's another one. Ice. Ice is another example of weathering. Just like Bill Nye said, if there's a rock and there's some cracks in the rock, and then ice gets into the cracks, and then suddenly the rock heats up, crack. And have you guys seen on the road, or maybe in your backyard if you have concrete, and it cracks? Like on the road we have potholes, and there are these big holes, and sometimes when you're driving all of a sudden you'll hit a hole. That's from weathering. Ice will get into cracks.